Hi there and welcome to our next video on fractions and reoccurring decimals. This is a continuation from our last video, but in this video we're going to be looking at some exam questions. So let's get started. Our first exam question states, change 3/11 to a decimal. So this divided by sign is known as the line which separates the numerator from the denominator. So all this means is divide. So we would do 3 divided by 11. This would give us 0. We add a 0 over here. 11 goes into 30 twice with a remainder of 8. 11 goes into 87 times with a remainder of 3, and this decimal will keep repeating. So it will be 0.27 reoccurring, and that would give you 1 mark. Prove that the reoccurring decimal 0.39 is 1333. So there are two ways we can do this. The first way is 13 divided by 33. So 13 divided by 33, and you can work that out to get the reoccurring decimal 0.39. Or the other way would be to convert the decimal into a fraction, and that's the way I'm gonna talk you through now. So x would equal 0.393939. If we multiply this, it would become 10x, and if we multiply this would become 3.99, 39, 39 and 39. Let's multiply this by again by 10 to get 100x. Now it would become 39.393939, and we multiply this by 10 as well. And now you can see the numbers after the decimal point are matching with x, which has 393939, and 100x, which has 393939. So now all we can do is we can do 100x subtract x, which would give us 99x, and we can also do 39.393939 and so on, subtract 0.393939 and so on. So that would end up cancelling out all the decimal places, and that's what we want. So we would just be left with 39 subtract 0, which would give us 39. So 100x subtract x would give us 99x, which is equal to 39. And now you need to get x by itself. So over here you divide by 99, and over here you divide by 99 as well. So your fraction, which is equivalent to 0.39 reoccurring, is 39 over 99. But we can simplify that. So let's divide the numerator and the denominator by 3. This would get us 13, and this would get us 33. And that's how we can prove that the decimal matches the fraction. This would be our proof, our working out. Next question, express the reoccurring decimal 0.213 as a fraction. So over here, let x equal the decimal. It would be 0.213131313 and so on, because you can see the dots are only above 13, so only 13 are reoccurring. Let's multiply this by 10, and we'll multiply this by 10 as well. Remember, we need to get rid of all the numbers after the decimal point. This would become 10x, this would become 2.13131313 and so on. Now we multiply this again by 10, this would become 100x, and it would become 21.313131 and so on. After we multiplied it by 10, we multiply by 10 again because the decimals are matching. This would become 1000x, and we multiply by 10 over here as well. This would become 213.131313 and so on. And now you can notice the 10x decimals, which are 131313, they're matching up with the 1000x decimals, which are 131313 as well. So now you can do 1000x subtract 10x. This would get you 990x. So that's step 1 done. Now we can do 213.13 reoccurring, subtract 2.13 reoccurring. That will get us 211 by itself. Now we have 990x. We need to get x by itself, so we divide by 990, and we also divide this by 990. So we have 211 over 990. That is our answer. And if you can simplify it, you can simplify it further down. Next question. Janet completes 4 steps out of 11 in order to unlock an achievement on her favorite app. What is the proportion of the achievement that Janet has completed as a recurring decimal? So she's completed 4 out of 11. And we need the proportion that she has completed as a recurring decimal. So 4 steps out of 11 as a fraction would simply be 4/11. And now you need to convert this into a decimal. So you would use this divide by sign. So it would become 4 divided by 11. 11 goes into 4 0 times, so you put a decimal place on and you add a 0 over here. 11 goes into 40 now, 3 times, so it goes 3 times with a remainder of 7. 11 goes into 76 with a remainder of 4, and this decimal would keep repeating. So our reoccurring decimal would be 0.36 reoccurring, and that would be our final answer. Next question. What is 0.6121212 as a fraction? So let's work through our workings again. So x equals 0.612121212 and so on. Let's multiply this by 10, and let's multiply this by 10. This would become 10x, 6.12121212 and so on. Let's multiply by 10 again. This would become 100x. We need to multiply this by 10 again, multiply by 10. This would become 61.212112 so on. Let's multiply this by 10 again. This would become 1000x, and it would show 612.121212 and so on. Now we can see that 1000x has 1 2 1 2 1 2 and so on, and 10x has the same. So what we can do 1000x subtract 10x. That gives us 990x, and 612 subtract 6, because all the decimals have cancelled out, this would then become 606. So 990 is equivalent to 606. So we divide by 990 here, and we divide by 990 there. 606 over 990 would be our answer, but we would need to simplify that in order to get full marks. Okay, last question. X is an integer such as 1 is smaller than or equal to x, which is smaller than or equal to 9. Prove that 0.0x is equivalent to x over 99. So let's see what we know. We know that x is an integer between this value. So we know it's going to be between 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the values which are between this algebraic formula, because it's either 1 is equal to or smaller than x, which is smaller than or equal to 9. So it's between these range, so it can be any of these numbers. So any of these numbers could be x. So let's test it out with any number. We need to prove that it's that. So let's test it out with, for example, 7. Let's take 0.07, where both the 0 and the 7 are reoccurring. X is equal to 0.07070707. Let's multiply by 10. 0.7070707. Let's multiply by 10 again. 100x is equal to 7.070707. And now you can notice this line has matched up with our first line. So what we can do is do 100x subtract x, which will get you 99x, which is equal to 7. And then we can divide this by 99 to get x by itself, and we divide this by 99. So our chosen value for x was 7 originally. Let's see if that works. We chose this as 7, this has to be 7, and our answer is equal to 7 as well. So that proves that the method works. So this is our proof to show that this equation is correct. If we picked another number, for example 2, it would be the same working out as well, and it would be the same answer. And that is it for this video. Thanks for watching. I hope you liked it, and one last thing, please subscribe, hit the like button and the notification bell.